Hello everyone, today we will see one of the best pocket-sized oscilloscopes, and at the same time within everyone's reach. In fact, it costs less than $20. We will also see how to upgrade its firmware, then ending the video with a very interesting change, which will make it portable and transportable anywhere at 100%. Follow me. Once purchased, as always you will find the links to do so in the video description. You will arrive well prepared and packed inside its box, electronics sealed, and updated to the latest hardware version available, as evidenced by this photo. The card code ends with 00E1. This DSO150 oscilloscope is available in 3 kits: completely assembled, semi-assembled, as you are seeing in the picture, or completely assembled, including all SMD components. In case you want to come across this last kit, know that you will deal with things of this size. You will not only get away with the simple stagnator. I therefore recommend the semi-assembled kit, the same one I bought. The semi-assembled kit will include the main board with display, already with SMD components installed. Second card, where the probe will then connect. Central key holder card. The complete case, branded JYEtech. A simple and economical crosshead screwdriver. Electronic components that we should stagnate us. An economic probe ending with 2 crocodiles. Together with 2 A4 sheets, where it is illustrated and explained with color photos, the few simple steps to assemble your oscilloscope. Just do not mess with the 16 resistances, and assemble it will really be a walk. Before heating your soldering iron, however, it is essential to test the electronics. Just power the main board with 9 volts. In my case, I came to the aid of a DC-DC converter to immediately see the lighting of the display, exactly as you are watching video. At the back of the card, a red LED will flash. Perfect. I would say that now I can heat the soldering iron and get something like this. Once finished, we can close it all up and adjust its probe through the 2 small trimmers. Et voila, your personal, inexpensive, and portable oscilloscope. Switch to select AC/DC or ground. Fasten to calibrate the probe with a 1 kHz square wave, and probe mount with classic bayonet plug. Caution: maximum 50 volts, or say goodbye to your new toy. 9-volt input, on-off switch. 4 keys on the front to set the measurement, and a practical trimmer to adjust, center, the waveform. Also recommended will be the purchase of a probe of this type, to make measurements at 10x, which otherwise we would not be able to measure, from 100 MHz, Series P6000, 6100 for precision. Brief information on its frequency compensation, list of various accessories, as well as the characteristics of the probe itself. Sachet with various accessories. Mass terminal crocodile. And harpoon probe, to facilitate its use. The classic tip is also present. Compared to the supplied probe, this also has a practical selector to set the probe from 1x to 10x. Its bayonet type connector exactly as it is on the oscilloscope, bearing the identification code of the probe itself, has a practical hole, where it will be possible, using a plastic screwdriver supplied, to adjust the measured wave. Important: when switched on, immediately after the manufacturer's logo, the firmware version of the same will appear. Self, as in my case, will arrive with the version ending in 111, or earlier. The firmware is not updated. The oscilloscope still works, but it is advisable to update it, especially if, as in my case, often rather than turning on, the message will appear, reading memory failed. For convenience, I will permanently attach this comb to the main board. At home I only have this 8-pin, For the firmware update, 1 from 3, ground, RX and TX would suffice. I'll position it this way, stagnating the pins on the back. The next step, in order to update the firmware, will be to short-circuit these two pins, called JP1 and JP2. Don't worry if tin plits fail, in 5 minutes we should remove them. Another essential component for the firmware update will be this Ttl Converter, serial, ERT. With this version, specifically, however, I found problems in finding drivers for Windows 10. I will therefore leave you in the description only the link of this one, 100% working without any driver problems. In fact, you won't even need to install them. When you say, plug and play, then 3 wires will be needed, with DuPont male and female. Well, female connector installed, JP1 and JP2 short-circuited. We proceed. We insert the first cable to the TX pin. In my case it will be red. Another cable, blue in my case, at the RX pin. And finally, the last cable, green, at the pin of ground. To the converter, we will simply invert TX with RX. Therefore, red will go to the RX pin. The second cable, blue, will go to the TX pin. And the remaining and last, green, at pin G and D. Perfect, everything is ready. We just have to turn on the computer and download the program called Flash Loader Demonstrator. I'll leave the link in the description. Open the manufacturer's page, JYEtech, and download the latest firmware version for the DSO150 oscilloscope. In my case it will be the number 113, released in April 2018. Actually, just yesterday, version 120 came out with the last, of course. Once the firmware and program are ready, feed our oscilloscope with the 9 volts. Insert the converter in the PC. Pay attention to the bottom right which port will be assigned, and let's start. If you do not know the COM port, go to the control panel, System, Device Management, look for the line, COM and LPT ports, and read the COM port of your serial converter. In my case, COM 8, but the converter is not working. The converter used below will use the COM 9 port instead. We just have to turn on the oscilloscope. A white screen will confirm that we are in firmware update mode. Start the program, Flash Loader Demonstrator. We set the COM port view just now, baud set to 115,200, leave selected, even and disabled, and we set a 5-second timeout. And we press next. Perfect green light, so let's continue with next. We would now have a list of readable addresses. We leave the target set at 64K. We do not touch anything and proceed with forward. At this point, we select Download on the device, so the various fields will become writable. Click on the 3 dots on the right, select the network path of our firmware file, desktop in my case. If it is not visible, we set the search for files with extension, hex at the bottom right. Select the correct file and press Open. Let's make sure it is selected, erase necessary pages. We also check the checkbox, optimize, remove some FFs, and leave the verification inserted after the download. We don't touch anything anymore. Everything is fine here. Let's proceed with next, and wait for the term. I was hoping you would notice a few flashes on the serial converter. Instead, nothing. Patience. Perfect. Download operation completed successfully. We can then close the program, put the PC aside, turn off the DSO also. Let's unplug the 9-volt plug. We also disconnect the converter from the PC. And we eliminate the converter cables. We just have to unsolder the two short circuits, JP1 and 2. And turn the card back on to prove the correct operation with the new firmware. So, very hot tinning and meatball sucks tin. 1 and 2. A quick cleaning at the 4 pitches. Et voila! Some flux halo. But don't worry. Power supply 9 volts and switch on. As you are seeing on video, the firmware version is now updated to 113, and no longer to the previous 111. Splendido. We closed the whole thing, but not before having transcribed the serial code from 8 alphanumeric characters of our card. During the initial boot, check that the code written on the label matches the code that will appear at the bottom center of the screen. If not, you have run into a non-original product. Therefore, contact the seller for a solution. In fact, this code will be used to request the release of the new firmware directly to JYEtech. To update the firmware, from version 110 onwards, JYEtech has introduced a firmware level lock, which can be unlocked only through the unique personal code that you will send yourself within 24/48 hours of the request, as long as you have an authentic, clear product for your hands. Just write 2 lines directly to JYEtech at gmail.com, reporting all the data of your card, model and serial in particular. JYEtech will reply to you with an email, with the 4-character unblocking code in the first line, along with a short list of operations to be performed in sequence to unblock. Let's see them together. With the oscilloscope now updated and turned on, we should keep these 3 keys pressed for a few seconds. Sective, trigger, and adjust. 1, 2, and 3. And here is the menu we need for entering our unlock code. We rotate the ring to change the characters, a short click on it to go to the next. And at the end, a click on OK to confirm. End. But of course, instead, to calibrate the probe, simply connect the red test lead or crocodile to the test fasten, with the other black end of the probe disconnected. Press the ADJ key for a few seconds, set the amplification to 0.1 volts, set a value of 50 millivolts, for a time of 0.2000 seconds. We keep pressing ADJ to exit. A long press on OK will display more details about the measurement on the screen. A short click on OK, instead, will freeze the screen for a better consultation. Given the small size of the SDO150, it is a real shame to have to feed it every time with a transformer, but this problem was solved by Gianluca Arena and Osvaldo Colalti, creating this useful kit to make his own oscilloscope pocket-sized in every respect. But let's see right away what will come at home after the purchase. I leave the product page here, top right. A simple and practical summary scheme, as well as the case, made with a 3D printer. From the same appearance as the original JYEtech. Slightly more roomy, but at the same time maintaining a compact and portable line, perfect for holding any lithium battery, and the rest of the kit. by purchasing the complete version, you will also receive a battery recharge card, the mini version, or micro USB, and a DC converter, to increase the battery voltage from 3.7 volts to a suitable oscilloscope voltage, 9V, together with a practical switch, with perfect dimensions for this new case. We would therefore a bigger case, a light guide to monitor the battery charge, a battery charge card, in my case mini USB, DC converter step up, and a mini switch that will exclude the battery power supply. We should then purchase a 3.7 volt lithium battery, or a slightly more difficult to use lithium battery, like this from 3000 amps, or a cheaper and more compact version with 850,000 ampere. All will be fine, provided they remain within this volume, 73 to 55 millimeters, maximum thickness 5.5 millimeters. In my case, having a single cell type truck trailer, used for small indoor drones, I will use just one of these very small LiPo, from just 380,000 ampere hours, and soon I will reveal its autonomy, together with the DSO150. We would then also need a diode. I don't know if a video can read, type 1 and 5819. Be careful not to use other types of diodes, apparently all the same, like these 10 different specimens, but each one will have its own acronym, and each one will have different characteristics and uses. The 5819 Schottky is of the ultra-fast type, and cannot be replaced by a standard 4007. A 220 microfarad electrolytic capacitor from at least 16 volts will also be required, to be placed at the output of the DC converter, between the positive and the negative. If you can find a better one with tantalum, better if SMD, like this one, it is preferable the latter. And to finish, some cable, at least 26 AWG. Well, now that we have also recovered the battery, the diode, the capacitor, the cable, we send a few words about the TP4056 charging circuit. This circuit for charging lithium batteries accepts an input voltage of 5 volts, just like the USB standard. Inside it will have various protection circuits, about overload, short circuit, anomalous temperatures, and will intervene by disconnecting the load when the battery drops below 3 volts, just to preserve the battery itself. As it is not ideal for all types of batteries. Used with a 3000 mAh battery, or higher, you will not need to do anything. Unlike in all other cases, such as mine with a battery of only 380 milliamps, it will be necessary to intervene with the replacement of this resistance, called R3, by default. In fact, this resistance is 1200 ohm, and will allow a power supply electric equal to 1 amp, much too much for a small battery like mine. Here, then, is that the manufacturer provides us with this simple table, where we can obtain the ideal current value, compared to the battery that we would decide to install. Like all rechargeable batteries, even more so if the LiPo type, a charging current as gentle as possible, will prolong the life of the battery, avoiding bursts or fires. The idea will indeed be to recharge the battery to 37% of the total capacity. In my case, 380,000 amperes. For 0.37, I will get 140,000 amperes. Looking at the multiplication table in the video, the value that comes closest will be the first, 130,000 amperes. I will have to replace the resistance R3 of the board, eliminating the resistance of 1.2 kilo ohms, and installing one of 10 kilo ohms. Or 10K. Here is therefore that we will also need an SMD resistor of a value suitable for your battery. In this case, my battery, like all the LiPo batteries I own, will have a maintenance charge of around 3.8 volts. This is a handy portable LiPo battery tester. But in this battery pack, I chose this other tester. It costs just €1.70, but essential to keep the battery status monitored, both to monitor the right maintenance voltage if you use LiPo batteries, and to monitor the remaining charge, if you have used a limited battery like mine. Just connect the two ends of the battery here, then in parallel, and at the simple pressure of the front button, These 4 LEDs will light up, depending on whether the battery is charged at 25, 50, 75, or 100% of its charge. I recommend, during the purchase phase, select 1S for 1-cell batteries, then 3.7 volts. This type of tester is practically perfect for this case. I wasn't sure at the time of his order, but now that he's physically in my hands, he's really perfect. We could decide whether to install it on the right side, where there is the new switch, or on the left side, where there is a light with a recharge indicator. I believe I will opt for the latter side, the left. Yes, it integrates perfectly in this case. Magnificent. And even closed, there is no obstacle with anything, or almost. In a moment during its installation we will see everything better. If desired, you can unsolder this button, extend 4 leads and install it where you like. In short, given the paltry cost, I also recommend the addition of this practical tester. In summary, everything should come something more or less like this. But now, let's start the actual installation. We eliminate the resistance R3 and stagnate the correct and suitable resistance for the chosen battery. I prefer to keep the wiring out of the house because the plot does not agree with the hot tip of the stagnant. We avoid deforming and ruining 3D printing right away. We then arrange the components at about the same real distance that they will occupy then inside the case, and with the schematic in hand, we make the circuit even. With just the parallel addition of the short-term tester, we would get something like this. Just pay attention to the battery last. Take one LED at a time, being careful not to make any short circuits of any kind, especially if the battery is 100% charged. Short test of the new battery status indicator. It indicates 2 LEDs, so a 50% charge. In fact, as we saw earlier, it is currently at 3.84 volts of charge. With paper tape, we perform a quick guide, and we make the 5 holes, like this. We apply Kapton tape, resistant to high temperatures, and apply hot glue from the inside. We wait for it to cool, and remove the tape. Et voila, this is the result. Magnificent. A manual drill is exceptional for these simple and quick jobs. For the small button, the game is also simple, using a piece of filament for 3D printers. It is slightly heated. If you don't have plasma in your home, the flame of a common lighter is fine. A few seconds to soften and dissolve the plot, and press it firmly on a cold surface. A glass or mirror is perfect. Our button is ready. Shorten it to size, and insert it from the inside to the outside, so once the tester card is glued, it will no longer move. We apply strong double-sided tape, both under the 2 cards, and then where we will place the battery. We place the tester card with the LEDs, and with the help of the hot glue we stop it there, avoiding to apply glue where the light guide will be installed, or the recharge card. Well, now is the time. Double-sided adhesive. We fix everything to the case. Switch moment. With light pressure, we insert the switch into its housing. I added a drop of hot glue, you never know. And lastly, moment driving light. Here too, gently, we insert the light guide into the half-moon-shaped hole. Well, almost forgot, at the output of the DC-DC converter card, before going to the oscilloscope, we insert the diode in the positive 9-volt pad, and, at the other end, we will seal the positive LED. Between the positive and the negative, paying attention to the polarity of the capacitor, we apply a little bit of tin and fix the condenser there. Exactly as shown on video. Perfect, everything ready for final assembly. Let's take our DSO150 and open it. This Xiaomi magnetic pad is really convenient for not losing tiny screws. Watch. We recover the second electronic card. We eliminate the base of the DSO150, which now we will no longer need, and let's go to install it at the new case. A few seconds to understand that something is not coming back. This last card collides with the tester card, which I installed exactly in this point. No problem, it would have been better to have noticed it before having glued everything together, but anyway, nippers in the hand, it will be enough to remove the angle of the tester card a little, and you're done. Problem solved. We proceed. We complete the assembly, which we already know. Here, for convenience, I have replaced the DSO150 connector, suitable with the pre-assembled piece of cable used by me. Short test, with connected oscilloscope, everything is okay. Before closing everything, we turn on the switches, 1 and 2. Firmware release, 120, perfect, everything is okay. First ignition by battery, pass test, positive. And here is our Moto DSO150, completely portable, autonomous, thanks to the internal battery, which can be consulted with a click. 50%, perfect. We just have to recover a battery charger from smartphone, mini USB cable, and make the first charge. Maybe during the charge, let's place it on a non-flammable surface, and keep it always in view. You never know, with lithium polymer batteries, better to always be careful. And we wait for the light, from red to green. Its consumption, with a normal 5-volt power supply, USB, is only 70,000 ampere. Actually, my first charge was performed with the oscilloscope completely open, on the work table, to visually monitor the battery, and its temperature. Obviously, a couple of hours time, and it has reached its maximum charge without any problem. Charging the battery to 130 milliamps, it takes 2 or 3 hours, depending on whether the battery was completely discharged at 3 volts, or was at the maintenance voltage, as in my case, at 3.8 volts. Finish. We disconnect the battery charger. "100% battery, 4 are in fact the lit LEDs. Once charging is complete, the voltage across the battery is around 4.2 volts. While at the exit of the step-up, the measured voltage is 8.98 volts, exactly like with a 50% battery, before the full charge. This simple tester is read as follows. 100%, so 4 LEDs lit up will have a battery voltage of 4.2 and 4.1 volts. As soon as the battery drops below 4 volts, 3 LEDs, 75%, will light up to a voltage of 3.85 volts. Under 3.85 volts only 2 LEDs will light up, 50% battery. Once down to 3.65 volts, only 1 LED will remain lit, the minutes will be really counted, and my advice is to not reach 0, and then stop here. At the exact moment when the third LED goes off, you will have the battery with the correct maintenance voltage, or 3.8 volts. Therefore, when you are not using the oscilloscope for long periods, recharge it until 3 LEDs light up, disconnect it from the recharge, turn it on and monitor the discharge continuously. As soon as the third LED is missing, we can turn it off and put it away safely in a drawer. Caution: never, Ever leave the oscilloscope stopped with a fully charged battery, 4.2 volts, or completely discharged, 3 volts. The batteries are very delicate. Neglect of them leads to a swelling of the battery, with possible leaks of gas not entirely healthy, including explosion and/or fire. But let's move on to the duration test. I open the bets. According to you, with a 380 mAh battery, how much autonomy will I have with this oscilloscope? Stay here, and you will find out. Now 16 o'clock, power on. Obviously, the tester will indicate 4 LEDs on 100% charged battery. After the first 10 minutes to measure, 4 LEDs are still lit. After the first quarter of an hour, 3 LEDs light up. Well, 20 minutes from power on, 3 LEDs light up. 25 minutes, 3 LEDs on. 30 minutes, 3 LEDs on. 35 minutes, 2 LEDs left. 40 minutes, 2 LEDs left. 45 minutes, 2 LEDs left. 50 minutes, 2 LEDs left. 55 minutes, 2 LEDs left. After 1 hour, pray for us. Ops, I meant 2 LEDs left. 65 minutes, 2 LEDs left. 70 minutes, last LED, last minutes. 75 minutes, last LED, last minutes. And exactly 1 minute from the 15th measurement, the oscilloscope turned off. Add a whisker from the measuring 80 minutes. Not bad, really not bad. More than enough for the use I will make of it. The battery tester refuses to give an indication, absolute 0. At the output of the charging module, the voltage is no longer present, in fact it has entered protection. Measuring directly at the ends of the LiPo battery, on the other hand, the voltage is just 3 volts, very low voltage. A further discharge and would have been damaged. 380,000 amperes, 80 minutes of autonomy, more than satisfied. Well, to practice some measurements, we could buy a wave generator for about €5. Find the link in the description, or download the Android app called Function Generator. Let's download it, install it, and open it. Oscilloscope in hand, we retrieve a simple audio cable with 2 male jacks, male, 3.5 millimeters, and connect the probe in this way. Connect the other end to our smartphone. If you still have the headphone jack output, clear. First of all, to the section, exit, we eliminate the right channel, and we click out to generate the signal. After that, based on the headphone volume set on your phone, adjust the oscilloscope. In my case, I will set it at 20,000 volts, and a time of 2,000 seconds. We would thus have our 100 Hz square wave. We could also vary the waveform. Sinusoidal, always at 100 Hz. Or triangular. By pressing the button, duty, we could change the duty cycle of the wave. 88%, 66%, 30%. You can also enter a precise value by clicking Enter Value. It will also be possible to vary the wave amplification. 100% for example. Bring it to 11%, or enter a precise value, 50%. With the key bias, distortions can be corrected. But don't ask me how, I have absolutely no idea. While pressing phase, you can change the phase. Ditto here too, don't ask me questions, thanks. The best test will be to change the generated frequency to understand if our oscilloscope performs a correct and true measurement as possible. 212 Hz, 20 Hz, 258.08 Hz, measured 258,112 Hz, great I'd say. Good for other waveforms too. "500 Hz, exactly. Pressing skew, you can vary the inclination of the wave, 76% rather than 100%. 0% or 45 or 30%. You can have a modulation of the FM signal or AM. You can also generate white noise. Or pink noise. Finally, click on Out, and many greetings. In conclusion, unfortunately the words were many, and I have not been able to be more synthetic than that. I thank you therefore if you have come this far with the vision. What else to say? This oscilloscope is truly exceptional. Given its price, I never expected this. Having made it portable, then, thanks to the additional kit, allows it to be used anywhere, at 360 degrees. Don't forget to leave a video like if there was help, you liked it, or simply found it interesting. Sign up for the channel, and activate the notification bell so you don't miss future releases. I await you at the next video. Ciao.